Rediscover Algebra and Trigonometry. Unfolding the Golden Ratio, the math behind the beauty. From seashells to sunflowers, from ancient temples to modern logos, there is a number quietly shaping our world. It's called Golden Ratio. In this particular video, which is part of our book, Rediscover Algebra and Trigonometry, we are going to provide you the math behind the golden ratio in a very simplified way. Let's first understand what this golden ratio is and what actually the problem is. Great. So, a golden ratio is defined by letter phi, which is equal to 1 plus square root 5 over 2. This is a Greek symbol pronounced as phi, phi. Now we have an ordinary looking rectangle right here. However, it has a peculiar property, and that is if I remove a square from it, so that's the square, in that case, the leftover rectangle is similar to the original rectangle. The leftover rectangle, EBCF, is similar to the original rectangle, ABCD. Clear? Right, so that is what it is. And this golden ratio is defined by the length of the side of the triangle to the width of this triangle, which is also the width of the square which is removed. Perfect. So I hope you have understood this question. So basically, the key property here is that when a square is removed from a golden rectangle, the remaining rectangle is similar to the original, meaning the ratios of their sides remain the same. So the rectangle ABCD, the bigger one, is a golden rectangle. Point E, which is right there, lies on AB such that AE is the side of the square constructed inside the golden rectangle. We need to prove that AE plus EB, the whole length, over AE, the square width, equals to AE over EB, and that is phi, and should be equal to 1 plus square root 5 over 2. Clear? Let's begin with the proof now. So, in simplified words, we have this particular big rectangle. Since the golden ratio phi is given to us as the ratio of the length A to B over A to E, right? Now, A to B is sum of these two also, right? So what we are going to do is we are going to take AE as one unit and A to B as x. So the golden ratio will be x. Is that clear to you, right? So this ratio basically is x over 1. Now, big triangle is similar to the smaller triangle. So the bigger length of the big triangle comes on the top, that means bigger length of the smaller triangle, which is BC, right? Over the smaller length, which is EB. So what is BC? Well, BC is same as 1, correct, the width, and E to B is x minus 1. You see, once you understand the question, then it is very easy to write an equation. This is kind of a proportion since we have similar rectangles in this particular case. Correct. Now let's solve it by cross multiplication. So we'll cross multiply x times x minus 1 equals to 1. x squared minus x equals to 1, x squared minus x minus 1 equals to 0. Quadratic formula will give you the value of x minus b means 1 minus of minus 1 plus minus square root of b square, which is 1, minus 4ac, 4 times 1 times minus 1, right, over 2a, 2, right, a is 1. So that gives you 1 plus minus square root of 1 plus 4, which is 5, right, over 2, that is 1 plus minus square root of 5 over 2. Now clearly we cannot have minus square root 5 from 1. That is going to give us a negative value. And therefore the valid answer will be 1 plus square root 5 over 2. Is that clear to you, right? So we just shown here that the value of x is indeed 1 plus square root 5 over 2, since this is the only valid answer. I hope it makes sense. Perfect. So feel free to send an email on globalmathinstitute@gmail.com or contact us on our website for more details on this book, Rediscover Algebra and Trigonometry. Thanks for your valuable time and all the best.